Hi everybody, welcome to another video in Differential Equation, section 6.4, Variation of Parameters. This time we apply to a higher order of equation. So variation of parameter we studied in section 4.6. In that section we only have the function of the second order equation, meaning that we only have a 2 by 2 in the wrong skin, and we use grammar rule. So pretty much exactly the same thing what we have here, but we just set up the variation parameters still in this form. So first, of course, we solve for the auxiliary equation, get the complementary solution, and get the wrong skin, and from there we will use the variation parameters and then use Cramer's rule to solve for the derivative of the v's and then integrate to get back to v, and at the end we have the solution. Alright, and a problem like this usually will take a lot of time to do, so I only do a problem, maybe two, in this lecture. In the description, in the link, in the description below, I will put the link of a few more examples. Those will come from the final exam review, so you can just watch those videos for some problem involve variation parameters. So the method itself is not that complicated. It's just that sometimes the function is difficult to integrate, and so we'll see. Anyway, so what we have here is the only thing that we need to pay attention in the variation parameter is that what will we use. I mean, don't even try to memorize all of that. I'm not even trying to memorize any of this. We use the Cramer's rule, and in the Cramer's rule, make sure that the input function, make sure the leading coefficient is 1. Yes, so the only thing that pay attention here is that the leading coefficient should be 1, so the calculation will be a lot easier if the leading coefficient is 1. Alright, variation parameter to solve this problem. So the first step is always get the complementary solution. We need to have that y1, y2, and y3. So first, complementary solution. So from here we write the auxiliary equation. Third derivative r cubed, second derivative r squared, derivative r, and auxiliary equation is from the homogeneous equation, so that will be equal to 0. And then we solve for r. I'll factor out the r. We have r squared minus 5r plus 6. And then factor out one more times r minus 2, r minus 3. So we will have r equal to 0, r2 equal to r minus 2 equal to 0, so r2, and r3, r minus 3 equal to 0, so r equal to 3. So we have solution y1 is e to the 0 x. We use x here, so just 1. y2 e to the 2x, and y3 e to the 3x, and from there we have the complementary solution c1y1 c1y1 plus c2y2, and then c3y3. Right. So that's what we have. Right. Next, Next, we will go to particular solution where we use the variation of parameters to particular solution. Where we use variation of parameters. Right. So first, we will. By the way, once again, the leading coefficient is 1, which is good. That's important. Variation parameters. There are 3. Y1, Y2, and Y3, so the particular solution will take the form of V1, Y1 plus V2, Y2 plus V3, Y3. Right. Where we have this system of equation. Right. Y1 V1 prime, Y2 V2 prime, Y3 V3 prime equal to 0. Y1 prime V1 prime, Y2 prime V2 prime, Y3 prime V3 prime equal to 0. Y1 double prime, Y2 double prime, Y3 double prime equal to, not equal to 0, whatever the input function. If the leading coefficient is 1, then we're just going to take that. If not, divide everything so that the leading coefficient is 1. So we're just going to take that, negative 24 e to the x, e to the 3x. Right, so we have that system of equation. Now using Cramer's rule, first we will have the wrong skin. The W will have Y1, Y2, Y3, the derivative, second derivative, Y1, 1, Y2, Y3. Y1 is 1, Y2 is e to the 2x, and then e to the 3x. Derivative 0, 2 e to the 2x, 3 e to the 3x. Second derivative 4 e to the 2x, 9 e to the 3x. Now this is just a 3 by 3 determinant. Since we have 1, 0, 0, I will evaluate based on that first row. Yeah, so that will be equal to, we're going to have 1. The sign chart for the 3 by 3 determinant. The 1 stand on the plus, so we have 1. We do along the first column here, and after that cover the row and the column that containing the element. We left with 2 e to the 2x, 3 e to the 3x, 4 e to the 2x, and 9 e to the 3x. Cross multiply and subtract, we have 18. E to the 2x, e to the 3x, we combine the exponent, e to the 5x. Subtract 12, e to the 5x. So subtract and we have 6, e to the 5x. Right. The order we have 0 and 0, that's why the determinant we don't have anything else, so that's just 0 and 0, so that will be nice enough. That is W. Next, W1. For W1, we will replace this column into y1 and y derivative of that. So 0, 0, negative 24e to the 3x. But the other two will stay the same. Yeah, we can just copy that. y2, y3, y2 prime. Alright, 0, 0, negative 24 e to the 3x, e to the 2x, e 2e to the 2x, 4e to the 2x, e to the 3x, 3e to the 3x, and 9e to the 3x. Now, 3 by 3 determinant, we have a bunch of zeros here, so once again we use the first column. The negative 24 here stand on the plus side, so we don't do anything to it. And we will cover the row and the column that containing that element. So we should have e to the 2x, e to the 3x, 2e to the 2x, 3e to the 3x. Right, multiply negative 24 e to the 3x. Multiply this, we have 3e to the 5x. Subtract 2e to the 5x. So that gives us e to the 5x. So we have negative 24 e to the 3x. Inside the parentheses is e to the 5x. Combine the exponent, give us negative 24 e to the 3 plus 5 is 8. That is W1. And now W2. W2. I'll replace that into row 2. The first one we still have y1, y1 prime, y1 double prime. And then for y2, replaced by the last column. So the grammar's rule here, it's just a bit tedious. But systematically, it's not that bad. Especially in this case, we have a bunch of zeros. 1, 0, 0, 0, 0, negative 24 e to the 3x. And then e to the 3x, 3e to the 3x, 9e to the 3x. Right, then we can choose a lot of rows or any row and any column as a bunch of zero. So I will choose, with respect to the first column, I only have one stand on the plus sign, so it's 1. And then cover the row and the column, we will have 0, 3e to the 3x, negative 24 e to the 3x, and 9e to the 3x. 1 stand on the plus side, so we don't do anything. And for zeros, we don't need to write that because 0 times anything is 0. Right, so that could be 0, and that 3 times 24 is negative 72. E to the 3x, e to the 3x, 3x and 3x combined give us 6x. Right, and then W3. Alright, first two columns will stay the same. And then for y3, because this is w3, replace the last column into the y3's and derivative 0, 0, negative 24 e to the 3x. Right, 1, 0, 0, e to the 2x, 2 e to the 2x, 4 e to the 2x, 0, 0, negative 24 e to the 3x. Right. Once again, I will evaluate based on the first column. So we have 1, cover the row and the column that containing 1. So we have 2 e to the 2x, 0, 4 e to the 2x, negative 24 e to the 3x. And multiply this, we will have, that's easy, 2 times negative 24 is, by the way, yeah, this is positive, this direction is negative, so that should be 72, right? Now this will be negative 24 e to the 3x, e to the 2x, that e to the 5x. Right, so we have all the w's. Now we'll find the v's. v1 prime is equal w1 over w. Right, w1 negative 24 e to the ax, w6 e to the 5x. Evaluate that, give us what? Negative 4 e to the 3x. Right, so that is v prime. So to get back to v1, just integrate. And we have negative 4 over 3 e to the 3x. Yeah, for variation parameters, we don't need a constant c, so we just have that. Now v2 prime. w2 over w. w2 is 72 e to the 6x divided by w6 e to the 5x. 72 divided by 6 is 12. Is 6x e to 5x. 6x minus 5x is just x. And then we integrate. Which is 12 e to the x. v3 prime is w3 over w. w3 is negative 24 e to the 5x. And then 6 e to the 5x is w. Divide them, we have negative 4, negative 4. So we have v2 if I multiply this correctly, sorry, that's 48. Can even do the math. Sorry. Yeah, negative 48. and 48 divided by 6 is 8. Sorry. So integrate negative 8 dx is going to be negative ax. That is v3. Right, so we have all that. Now we go back to the variation of parameters. Particular solution will take the form of v1 y1 plus v2 y2 plus v3 y3. v1 that y1, yeah, y1 is 1, y2 is that, and y3 is that, times 1 plus v2 y2 plus v3 and y3. So that gives us negative 4 over 3 e to the 3x. Multiply this, give us 12 x and 2x. Add the exponent e to the 3x and minus ax e to the 3x. Right? These are like terms. 12 minus 4 over 3. I get fraction 32 over 3 e to the 3x minus ax e to the 3x. So we have the particular solution. Finally, we have the solution, complementary solution plus particular solution. From the previous page, complementary solution C1, C2 e to the 2x, C3 e to the 3x, and particular solution. Right. So let me try to zoom out so we can see the whole problem. Alright, so of course it's just Cramer's rule, variation parameters that, and then we have the system of equation using Cramer's rule. It's not much here. Just make sure that when we do this, the leading coefficient for the highest order of derivative, make sure that it is 1. When that is 1, it is a lot easier. We're just going to put 0, 0, and whatever that input function at is. And then we have that Cramer's rule, get all the w's, then get the derivative of the v's, integrate to get back to the v's, and then put it back. We have the solution. So it's not that bad. Right, as mentioned before, I'm going to put a few more videos in the description because this problem is very long and tedious. So I don't want to make a too long of a video. Next, we will look at the Cosiolo equation. Yeah, I'm not sure how far we can get from this because this will be very long. So this is the Cosiolo equation. The first part, of course, we look at complementary solution. Right, this is Cosiolo equation. We have the degrees of x is the same as the order of derivative. So it's not auxiliary equation right away. First we'll let the solution be the form of x to the r. Right, so we can take derivative. Second derivative. And then third derivative. Right, and then substitute back into the homogeneous equation. Right, so x cubed and then third derivative r minus 1 r minus 2 x, well, plus x squared second derivative r minus 1 x r minus 2 plus, minus 2x derivative r x to the r minus 1 and then plus 2 times the function. Right. All of this we can factor out x to the r, x to r minus 3 times x to the 3 and 3 cancel out. We have x to the r is the common factor. We have r minus 1, r minus 2 plus, now this common factor, we have r minus 1 left. And then we have minus 2 r plus 2 equal to 0. So factor out x to the r on all of them. Now multiply them out. Should be x to the r. So multiply this out. That will give us all of this square minus 3r plus 2. Now multiply by r, so give us r cubed minus 3r square plus 2r plus r square minus r minus 2r plus 2 equal to 0. Combine like terms. R cubed 3r squared, that gives us minus 2r squared two r cancel out, just have minus r plus 2. Alright, so it's not that bad. Both of them we can factor out the r squared here from the first two terms. we have r minus 2. And then from the last two terms, we factor out the negative. So bottom line is we have x to the r squared minus 1, r minus 2 equal to 0. By the way, this works for every r or every x. We'll have to have r squared minus 1 and r minus 2. So this kind of like the auxiliary equation or characteristic equation. We're just going to drop the x to the r. But we factor out one more time. R minus 1, r plus 1, that for r squared minus 1, and r minus 2 equal to 0. So we have r1 is 1, r2 negative 1, r3 2. Because of that, we have y1, y2, and y3. This is x to the r, so we have x to the first, y2 is x to negative 1, y3 x squared, and solution c1x, c2 x to negative 1, and c3 x square. Right. Next, particular solution using variation parameters. So v1 y1, v2 y2, and v3 y3. Right, and then that system of equation, right? y1 v1 prime, y2 v2 prime, y3 v3 prime equal to 0, y1 prime v1 prime, y2 prime, v2 prime, y3 prime, v3 prime. That one also equal to 0. Next, y1 double prime, v1. This one we will not complete the problem. I just want to get the w1, and then to get the idea. Equal to. Now pay attention. We're not going to write equal to the input function, right? Remember, whatever function we put here, the leading coefficient has to be 1. So in that case, if we divide by x cubed on both sides, doesn't matter what we have for the others. No, we have 1 on the first one, but the input function x cubed cancel x cubed, so that's just sin x. Right, so make sure that whenever we put the function into the variation parameters, make sure the leading coefficient is 1 before you do anything else. So divide by x cubed give us sin x. So that's what we put here. Right, so that's why I do this problem, just want to bring that point up. Right, and then the w's. Still the same standard y1, y1 prime, y1 double prime, y2, y2 prime, y2 double prime, y3, y3 prime, y3 double prime. y1 x, y2, x to negative 1, x to negative 2, and 2x to negative 3. Those are derivative. And then we have x squared, 2x, and then 2. Those are the derivative. Right, determinant. 3 by 3 determinant. Right, so I will use the first columns here. So first, we have x. Cover the row and the column of x. We end up with negative x to negative 2, and then 2, x to negative 3, and then 2x, and 2. The x sitting on the plus side, so that's what we have. Next, we have 1. We have evaluate along this column. The 1 sitting on the minus. So we will cover the row and the column. That containing 1. We have x to negative 1, x squared, 2x to negative 3, and then 2. Right. To evaluate this, we have x give us negative 2, x to negative 2, and the other ways around would be 4. X to negative 3 times x is x to negative 2. Right. Then minus. This gives us 2, x to negative 1. Minus 2, x to negative 1. Right. So x, this is negative 6. X to negative 2 and 1 give us x to the negative 1. Yeah, that's negative 6, x to negative 2 times x. And this is 2x to negative 1 minus 2 x to negative 1. Well, that cancels out. So that turned out to be not that bad. Right. Now W1. Yeah, only do W1 and then get V from that. Because this is a long problem already. Well, we'll put that in 0, 0 sine x. Y2, Y2 prime, Y2 double prime, Y3, Y3 prime, Y3 double prime. Right, Y2, x negative 1, negative x to negative 2, 2x to negative 3, x squared, 2x, and 2. Right. This obviously we use the first column to evaluate. So on that column we will have sine x. Sine x sitting on the plus side. So that's what we have. So cover the row and the column. We will have x to negative 1, x squared, negative x to negative 2, 2x. So multiply that. we have sine x. Multiply that give us 2, and multiply that give us minus 1 to just sine x. Right, I said because of the problem is way too long, I'm not going to complete the problem. If we just want to find v1, so v1 prime will equal to w1 over w. We'll do sine x over negative 6 x to negative 1. So give us negative 1 over 6. X to negative 1 from the bottom move to the top, give us x sine x. Well, if we want to get back to v1, we have to integrate. And integrate this require integration by parts. So that's just even more complicated than it already is. But the point here is, for the Cosiolo equation, we still use the same thing. If we find the y1, y2, y3, and after that, variation parameters will be the same thing. Just make sure that the leading coefficient has to be 1 before we do anything, before we put in the system equation. Make sure the leading coefficient is 1. Right, as mentioned before, I'm not going to complete this one because that's longer than it should be. On this section, I put some more videos in the description, just so after you watch this video, just go down and there are a few links for similar problem in this problem. And those problems may come from the homework or may come from the final exam review, but we have some problem in this section, also very long. So that's why I didn't want to add to this video and make it extra long. But yeah, I'm just going to stop the video here. As always, thank you for watching and see you in another video in differential equations.